Hello everyone, it's October 30th, Saturday. We have a tough question, longest duplicate substring. I'm doing laundry right now, so I'll have to stop halfway to handle the laundry, but it should be fine. It's going to be a hard question. It's a string. I don't like it. But we're going to take a look. So, I don't think I've done this before. Nope. So, given a string S, consider all duplicated substrings contiguous of S that occur 2 or more times. The occurrences may overlap. Return any duplicate substring that has the longest possible length. If S does not have a duplicate substring, the answer is this. Okay, all duplicated substring. What do you mean by duplicate substring? Which is contiguous substring of S that occurs 2 or more times. So A and A occurs more times. Okay, once, A and A another times. Or duplicate. So this substring is duplicated. Alright? So a substring, a duplicate so that occurs 2 or more times, and occurrences may overlap. Return any duplicated substring, so any of them, that has the longest possible length. So the longest substring that is duplicated. And if there's nothing that's duplicated, return empty string. Okay, a string is always hard. And then only give like 2 examples. Banana, right? Banana is the example. So usually a string problem is dynamic programming, right? Most likely. Let's see if we can dynamic program this one. Consider all duplicated substrings. So we want a substring and it has to be duplicated. So the substring must start and end, right? It's contiguous. So how do I know if it duplicates? Like if I'm looking at a certain, right, that's usually how it goes. I'm looking at a certain letter and I want to know, this is a new letter, right? I want to know if there's any duplicate before me. How do I know if there's any duplicate before me? Let's say I have all the substrings ending at a certain one, right? And I also know if it has duplicates already. Okay. I know I have duplicates, and now I'm a new value coming in. So I can form a substring with the one before me. But how does that help me? So how do I, this is a question. How do I know that something is duplicate? I have 0 clue right now. Well, we want duplication, right? That means to have duplication, we must have letters that are repeated. Therefore, A, B, C, D is nothing. So we can like run a counter, right? We can run a counter and then to see, well, not really a counter. We just record the same position for each. The position for the same letter, like for banana, B is going to be 0, which means we don't have to consider this because it only occurs once. A, we have 1, 3, 5, and we have 2 and 4, right? That's how banana can be broken down. So once it's broken down, we take a look at, we get rid of anything that is a single value. Right, a single value, Well, actually, I put a single value. It's fine. I just single value is fine. Now, the only possibility to have occurs 2 or more times, it must be the letters that occur at least 2 times, right? So we narrow our search down to the letters that occur 2 times or more, 2 times or more. Okay, so that's fine. And in order for it to be because if it occurs more than 2 times, that's the same as occur 2 times. We don't really care how many times it duplicates. At least it's 2 or more times, right? So all we need to know, we can boil it down to, we want to find the longest substring that occurs twice, right? The longest substring that occurs twice. Okay, now we're trying to find 2 times. And we're going to look through everything that occurs at least 2 times. But I mean, it's like an elimination game, right? We can try to find all the possible, like everything that's not like. Let's say B and banana is not good, right? And N only occurs 2 times. So if the B is in between N, then we know the N cannot form, right? They cannot form. So we can just eliminate, right? We eliminate the possibilities. How? Like, do we have a preference, right? Like, if it's a 3-letter, right? If it's a 3-letter, yeah, we have to handle it no matter what, right? If it's a 3-letter. Okay, let me think. So, let's say we look at A. A, we have 1 position, 3 position, and 5 position. If we're looking for a double, so it's going to be 1 and 3. It could be 1, 3. I mean, that's already length of 1, right? We already find length of 1. But then we're talking about 1, 3, and 1, 5, and 3, 5. That's 3 different scenarios. And what we're saying is, if we find a pair, then we're gonna start the pair going on both sides and try to see how many we can match. Okay. Right, we're trying to match. Like, if I look at N, I can look to the left, we can go 1 time. I look to the right, we can go 1 time. So in total it's 3. And once we've done that, we know that some of the A's have been used. And that is deterministic, right? Because I used it, then that's it. So what if, instead of a list, we turn that into a set? Right? We'll turn that into a set. And then we start from the set with 2 values. Right? We start the set with 2 values. Okay. We start with the set with 2 values. And then, because that's deterministic. If there has to be repeats, then those 2 values, then we start grow to the left, grow to the right. And each time, if we encounter, like each time if there is something the same, and then we can remove that index from the dictionary. Because if we go back to, like if I have N, right, 2 N's, and then we go here, we encounter A. So we can remove these indices from A, because we already considered by N. Like, because if I consider A, I will have to consider N as well. So we only need to consider once. Okay, so we start from n, we go left, and anything that's the same, we remove them from the dictionary. But of course, if there's nothing, then n is gone, right? And every time when a letter is done, then it's gone. Okay. How do we go through this? They're basically saying we want to find that all the let me see. What we can do. What can we do to pop out the values that only have 2? Only have like 2 repeats. We start with 2 repeats, and then we're gonna go to 3 repeats, right? But if it's 3 repeats, we take 1, 2, right? But we need to take 1, 3 as well. Now it has to be 2. But eventually we'll have to handle the 3 situation. What if the 2 situation doesn't give us anything? Then we'll have to do the 3 situation. If it's a 3 situation, and I remove it, that's not good, right? That's not good. And we're going to time out anyway. Because it's going to be a pairwise, right? A pairwise it takes a long time. Like a long time. Gotta be a better way. Alright, I need to do the laundry. I'll be back. Laundry might not be ready. Do one more round. Alright, I'm back. Still no clue. I mean, we did figure out that it has to be a duplicate, right? But now the problem is we cannot remove. I mean, we can only remove if it's a 2, like a real duplicate. But if we have occurrences 3 times, then we cannot say we do the first 2, and anything we see matches, we can remove it. That is not correct. Right? That is not correct. But even if 2, we cannot do that. Because if it's 2, can we remove? If we have a duplicate that occurs 2 times, and then we look left, look right. Anything that is, I would say we remove it. But then it is possible that, it is possible that no, we cannot remove, because it will interfere with further comparisons. So that's a no. Okay. So anyway, now we have this. Then what? to have contiguous if I am, can we break the problem down? Bring it down. Like if it's a 1, right? If it's a 1 letter, and that's empty, right? If it's 2 letters, right? If it's 2 letters, let's say BA is 2 letters, because each one there's no repeat, so that's a no-go. But if it's BB, then it should be B, right? If it's a BB, it's a 1. Let's just return something, kind of poking it. We're poking it and try to see if we can get something out of it. So let's say we have 2. Right, BB. This one shall return B, because B is a duplicate by itself. Yeah, B is a duplicate. Okay? So if it's 2, we just need to check if they're the same. And if they're not the same, that's another no-go. What about 3? Let's say we have BBA with 3. So we know for 2 we have a value. Now we add a new one, right? So we want to first know if the new value has any occurrence in the previous. If the new value has no occurrence in the previous, then the result shall be the same as the previous. If the new value has occurrence in the previous, that is when the problem gets trickier. So let's say we have a bunch of string, right? And then a new value comes in, which has not occurred before, then we don't do anything. But if it's a value that has occurred somewhere, if it occurred once, right? Then we can, let's say I know the longest, right? The longest duplicate ending at a certain value. Let's just say I know the longest ending at a certain value. I know. Now I find a duplicate, right? If the new value has to be incorporated to be the new longest, then the string must end in A, which means we'll go back to the duplicate position and see what is the longest there. Actually, no, not what is the longest there. We just compare to see if this can create a duplicate. Which means, right? Which means if the just hold on. I think I'm getting there. Let's say we have the longest already. Right? Let's say we have the longest and the longest duplicated, right? The longest duplicated ending at any position. I know this. I know 2 things. The longest overall and the longest ending at any position. Now a new value comes in. If the new value has no duplicates, then the longest ending at this will just be itself, right? Because there's no duplicates. Okay. But if it does have a duplicate, then we find the duplicate. Now the duplicate will only have by itself because at that time it's just by itself. But we should look at one position before and see what is the length of one position before. If the one position before has something that's duplicate, then I can add the new one. It will be like append to it, right? And then we have it. Then we have a new one that's ending at this position, and we compare. Let's see if this scheme works with banana. So we have banana, right? So we say B by itself is just by itself. So the length is not only the length. What do we want to record? We want to record the actual. Now we can record the length. The length is 1. A come in. A not occurred before, so the length is 1. n comes in, n not occur before, so the length is 1. Now new a comes in, right? The second a comes in. So the previous a, we also record their positions. So we know their positions. The previous position, we know all their positions. So the new a comes in, and we'll look at the previous position is 1. So we look at the value before 1. That's a b, right? So we want to see how long is, or we want to see if we look forward, right? If we look forward, if that value is the same. Yeah, it has to match. It has to match. Hold on. What are we trying to do? The length of the duplicate. No, they don't have duplicate, right? Because it's by itself, so there's no duplicate. The length of the duplicate is string. So this charge is 0. B is 0. A is 0. N is 0. The length of duplicate, because there's no duplicate, is 0. So now A comes in, right? And the only chance for A to have duplicate is N, the one before it. If N has a duplicate, and that duplicate has to be occurring before A as well. So what we should do is we're going to check the previous A, and we check the before it is a B, and now before A is N. They don't match. So therefore, they do not match. Right? They do not match. What if they do match? If they do match, so we know for A the duplicate length is 1 already, right? It's 1 already. So we just want to see before it and before it. And we have the longest duplicate ending at this value, right? Longest duplicate ending at this value. So longest duplicate ending at this value and ending at this value. So longest duplicate ending at this value will be something previous, right? It will be the same. But how do we, the longest duplicate, and if we have n and n and they're matching, right? What if they're matching? If they're matching for that one, it will be just 1, right? It doesn't have anything. So it's until this one. And this one will find the longest that starts from here. It will be some n in the previous. And then it will go forward. So we also need to know not only the longest, but like all of them. Hold on. Do we need to get all of them? If I have the longest starting from n going forward, going before, right? Actually going backwards. I mean, now is a no match. Let's just say it's a no match, right? Just to get it simple. It's a no match, then for this A, I record value 1. And I need to also record with whom I have a value 1. Let's say with, so the length is 1, and also know is the with position 1. And then I need to add myself to it, right? Add myself to it, that's actually 3. Now n comes in, right? N comes in. We have a duplicate, so we'll look at 2, right? We'll look at 2. Okay, 2, and then we'll look the value before, right? We'll look at the value before. And the current value, look before, is A. And the previous value before is also an A. So we want to know how long is this, has this been. Well, we're looking at A. A says it's a 1, and it does use the same A. Then for the current n, the length is 2, right? The length is 2, and I add this to it as well. The last one is A. So if it's A, now we have 2 options. Right? We have 2 options. So we have to go through. So I have 2 options. Then I look a value before me. Alright? A value before me is an n, and a value before this is an n as well. The value before the first one is a b, so that one is not going to work. But do I have to go all the way to the first one? If I have a certain value, I need to know which one to look for, right? I'd say we'll also record. And we'll also record what is the value in front of me. So I immediately see, okay, that's the value in front of me. Now we have these 2 n's, so I go to the n to see how many, so that n says we have duplicate of 2. But I also need to know if that's the same n, right? The duplicate of 2. If it's the same n, then that will be the maximum. Otherwise, because I just want to find the maximum I can, so I need to find the, basically it's not the most, it has to be, because I'm A, right? And I look for all the A's. Actually, I look for all the A's that has the same previous letter as me. So that narrows it down, right? And then among all of them, I need to know what is the longest that we can achieve. So I look at what's the longest that I can achieve at this position. Well, the longest will be, I will compare to every one of those. So I just want the largest at this position. Well, largest with n compared to all the other n's. Right? If I'm here, and then we have another n, and I want to know how, so because they're all n, so at least there's 1. I just want to know if there can be more. Right? If this n is 2, against whom is 2? Right? Yeah, so I can narrow it down to a bunch of NAs, right? Then we have a bunch of NAs, and then I'm looking at myself, this n. So this n shall record all of its matchings, all of its, so I say, I'll have 2 duplicates with a certain n, or 1 duplicate with certain n, right? And now I need a certain n, and one of the n's. So we check for every single one of them. And now we check for these, right? So it should be the position and then the number of duplicates. The position with number of duplicates. And then we check for the position, number of duplicates. So we go through all of these. This will give me the longest that I can have, right? The longest that I can have. So in my case, this A looks before this N, position of 4. So at position 4, this N says, with position 2, I can have duplicate length of 2. Right? With position 2, I have a duplicate of length 2. And now I have A at position 5, right? A at position 5. So I look before, I have position 1 and 3. Alright, so I need to check position 0 and 2, because they are the previous one. Because at position A, at 5, my previous position 4 is an N. So I need to see 0 and 2, which one is N. So I find 2 is N, right? And then I look at position 4, see what is the longest that it can match with position 2. And it says it's 2, right? Which means for me, it's going to be 3. And we also record it's going to be 3. That's quite convoluted, but I think this might work. The runtime is going to be, I don't know, but it might work. But before we do that, I need to finish the laundry. It's going to be very convoluted, which mostly means it's not going to be accurate. This is my thing. I wipe this. Put it here. I wipe this. Put it here. You're welcome. All right, back at it. Let's try to design the data structure to solve this. I'm gonna go through banana again. So we need banana. We need an overall dictionary. All right, we'll record each letter. So B comes in, and then B sees is nothing. So I'll record the position. So it's another dictionary. Its position is 0. Right. Previously, we don't have anything, so it's just going to be an empty dictionary. Now A comes in. Oh, and also it's a dictionary of what? It's empty. That means it's 0, right? So A comes in. A comes in. It has nothing previously, so now it's 1. Previous is nothing. And now N comes in. 2 is nothing. Now A comes in again, right? Now A comes in again. So it's A comes in again. This is 0, 1, 2, 3. So A current position is 3. So we check A. And we check A. We go through everything previous. And we find an A. Right? So A is 1. And what do we need to know from this A? We need to know what is this A's previous value. Okay, so this A's previous value is a B, right? The previous value is a B. So that's how we check. So it's a 1, and its previous value is B. Okay. Well, that's easy to check, right? So it's a 1, so we know its previous value is B. And my previous value is an N. So they're not the same. So for at position 3, I will have the previous position 1 will give me duplicate length of 1. Okay. Now next one is N again. So N at position 4. So I check position 2, right? Position 2. And at position 2 I have nothing. Alright, position 2 I have nothing. Because there is nothing. So now at position 4 I need to check at position 3. So at position 3 is an A. So position 2, so position 1 is an A. So I go into A. Right, so A and A is equal. So I go into A and A is equal. So I go into position 3. So we go to A, go to position 3, right? And I want to see what is its previous. How many duplicates can it get? So my target is position 1. So I check for 1. 1 gives us 1, right? So for my current position, N is 4, I can say that because it's a match, so at position so at 4, N is 4, I can have at position 2, and then give us length of 2, right? Yeah, length of 2, and that's a new max. So we have a new max is length is 2, and starting at a position 4, going forward, length is right. Okay, now next one, A comes in again, right? The last A at position 5. So I need to see the previous A, right? And my previous value, position 4, which is an N. So I need to see all my previous A's previous value. So for the first A, previous value is a B, which doesn't match. So ignore. Next one, previous value is 3, and previous value is an N, right? Is an N. So that is good. So what we are looking for right now is position 2, right? That's the previous position will be 2. So now I look at my position, I have 4, right? N. So I go to N, go to 4, and try to see if 2 is in it. If 2 is not in it, then that's a moot point, right? That means we only have 1 repeat. Yeah, why do we have 1 repeat? Because that's not the one we are looking for. Because if it doesn't exist, that means at the end stage, right? Because we're looking at, we want to match a position 2, right? Okay, position 2 is an N, because now a current N is position 4. So from A, I find an A, and I find the previous of A is a match. Yeah, so currently they all match. But I just want to know what is, like, how far it can go. Oh, yeah, it will definitely have it, how far it will go. So I'll check it will go for two positions. So at the current one, it's going to be 3, which means the last A comes in with position 5. I say I can match with position 3, right? I can match with position 3, which will give me a 0, 1, 2, 3, a 3 distance. So I record 3, 5, and I just return that. Okay, so there's only one more piece that requires me to loop through, which I don't like. So when I have a new value comes in, I look into the dictionary, right, and I see I have duplicates the previous. What I also want to know, right, so when we push in, we shall push in more than just my current value. It should be my current value and the previous one, all right, whether the previous one is good. So how do I do that? So I have my current value, so I need to look at my previous value. So what if we don't record the actual location, the position? We don't really need the position. What if we just record the previous value? Nah, we cannot do a previous value because the previous value might have multiple. Hold on. So if I record the previous value, right? So the new A encountered, I check my previous value, I can immediately see which A's I need to take care of, right? So I can go back to the previous value. Now, this previous value, what do they include? They shall include the same information, which is this A will be matched to which previous A and give me how long and what's the length. So this previous value just helped me to remove another layer of iteration, right? We find an A and we see, oh, it exists, and then I check my previous value, boom, and I have the bunch of records the previous A has duplicates with, right? Now, actually I don't want that duplicate with. It's A with duplicates with. No, now we don't want to see what A has duplicate with. I want to see what N has duplicate with. Right? Because I have a new A coming in. I don't want to match previous A's. Well, I actually do want to match the previous A's. But it's fine. It's fine. There's a previous A. They don't have N. So like these will match one of the previous A's. So this A, right, it just means at it should be N come in. As the previous is N. So we still need the location. Right, we still need the location. And the location and another dictionary. Right? So just this means the previous value is N. Okay? So now we have A, we have the previous value, we have both matching, right? So now what we want to see is for N, right? For N, what is the previous value is N. Okay, so previous value is N. Now comes in, I have the current A position, right? I have the current A position, and then I have a bunch of current A position, and each one will record how long the duplicates is one of the previous one. So now I match, I have an A, okay, then the previous one's N, I go inside, so these are the A's I want to look at, right? But these ones, Okay, we have A and N match. We match both, right? We already matched both. But the question will be on N, right? It's not on, okay? But this way, I need to see N. And N, because I have my current N, and I have a previous N. Right? I have a current N, and I have a previous N. So the current N, I want to see the current N, how much it matches with the previous. This probably, I don't think this is a good way. It has to be index, right? It has to be an index. It has to be index. So when I match with this, can I go immediately? I want to know the immediate. I want to know immediately, right? When I match, I want to know immediately the previous one. Okay, so I go immediate previous one. This will give me bunch of A's locations, and then for each of those A location, I will know what is the N's location, right? Basically, I will go my and look into the previous one, right? And do I go one by one? We actually go one by one on this one because that's the match. We match an A, and we just want to see if this N matches any of this N, right? So we go through. Come on. How do we go through? So it's an N, so we'll look through these N, right? So these N, that's the previous value. So these are all the potential matches. It's a double match, right? We're talking about double match, NA, right? So we have NA right now. So we match previously all the NAs that occurred previously. And then for each one of them, we have the N's location. We have the N location, which is just A minus 1, right? Just A minus 1. So we find all these N locations, and then we put into the dictionary, try to see which one is longest. And then we pick the longest one. That will be the new value. Very convoluted. Very, very convoluted. But let's give it a shot. Just one shot. If it doesn't work, you can check the answer. I don't even want to see the hints. We just check the answer. Okay, so here's the deal. Alright, so what we want is we want a an A and a previous and all of the indices in the previous, right? So we want a double match. It's a double match, right? We have a double match, and we have, let's call it DP. We also have a DP. So these are the locations, right? The locations, and each one, how much it matches with the previous one. Okay, so let's say for I letter in enumerate S. So what happens? Now, first of all, we're going to check. Let's see if letter is not in DP, right? If letter is not in DP, then double match. What if I have a B? Then we check in the double match. It means there's no double match, right? That means it's only one. No double match, and that's just 1. So there's nothing in front. So if letter is not in DP, then DP letter is going to be a new dictionary, right? And this new dictionary is going to be DP letter is going to be a new dictionary when they include the current in the index, and that's going to be empty, another empty dictionary if letter is not in DP. Okay. If letter is not in DP, how about the double match? If the letter is not in DP, well, I can still do the double match. I can check if I say if letter not in double match. Right? If the letter is not in double match, then we can put myself in, right? What it's going to be empty, so it's going to be double match letter is going to be an empty dictionary. Okay, so if none of this happens, it means the letter is in double DP, right? Letter is in DP and the letter is in double match, right? If that's the case, it doesn't matter. It could be in DP, but it's not in double match. No, it's only the first one. The second one, it could be not in double match. Alright, so a double match is current letter. I want to find the previous one, right? So it will be like this. Then we can handle the double match first. And I check the previous one. So if I is larger than 0, right? If I is larger than 0, so I need to check the double match, right? So we need to see if I have anything matching. So we say if double match letter, so the previous, so I say pre is going to be s I minus 1, right? So if pre is not in double match letter, right? If it's not in, that means there's nothing, right? There's nothing that I can do, right? There's nothing. So if there's nothing, what do? I say no match, right? No match. So we just say the letter is not in it, right? So now we should know the letter is in it. And I already done this, which just means there's nothing I can match with if it's not in. That means there's nothing I can match. Right? Nothing I can match. So basically, I need to do whatever this, right? If it's in double match, then we can try to find matches. And once it's done, right, once the match is done, because I have a previous value, so I should do double match letter and should we do default dict on this? Okay, this is just a list, right? It's just a list of indices. List of indices. So say double letter Yeah, I like this one to be a default dict. So from collections import default dict. Like these are a little bit too complicated. This one is fine. It's default dict with a list, right? So this I can just start append, right? Append current position. If I is larger than 0, if I is not, the first letter, it does not have anything in front of it. So the letter is not even in double match, right? It's not even in double match. Okay, so, but if it's not in double match, at least it needs to, like I need to know like all the ones previous to, like I still have to go through every single letter that is previous to me in the duplicate. I have to go through them, because if it's not a match, then I need, no, I don't think double match is necessary. Let's remove double match, make it a little bit easier. So again, if the letter is not in DP, it's the first time it has occurred. So I put it in and do this, right? And then we say, if I is larger than 0, it doesn't have to. If I is larger than 0, yeah, it has to, because the first one does not have anything. So if I is larger than 0, I have a pre. I have a pre. So what we're gonna do is we're gonna look through DP, right? Oh, DP I already put myself in. Shouldn't I put it in at the end? If letter is not in DP, so this current value is first, then we just continue. Right, then we just continue. If the letter is not in DP, which means the first time it has occurred, and there's no way, right? There's no way we can find a duplicate. So we just continue. Otherwise, the letter is in DP, right? If it's in DP. So we can just say else. If it's in DP. If it's in DP, then I must be larger than 0, because the first letter is not in DP. So if it's in DP, the I must be larger than 0. So we don't need this, right? Else, if it's in DP, we can find the previous value, which is actually, we don't really need to go through. So we need to go through every single one inside DP. So we just say for pre-I, say PI, sorry, PI, and it's going to be pdict in DP letter dot items. All right, so we get these out, and now I need to see so we say current cdict, right? It's current dictionary. Now we're going to compare PI, right? We're going to say if PI is equal to 0, or SPI minus 1 is not equal to SI minus 1, which is just the previous value is not the same, then that means there's only one, the duplicate length is only 1. So it's a cdict with the previous PI, it's going to be PI, right? CPI is equal to 1. So that's only 1 from my current position. Else, now they're the same, right? Now we have the previous position is the same. Now if the previous position is the same, then we need to look at the previous position. How do we look at the previous position? Now we have both positions, which is PI minus 1 and I minus 1. So we're going to look for I minus 1. So we're going to look into DP S I minus 1. So this will bring out everything, right? Everything. That's the and I need to go into n-1, I-1 as well. So this one goes into the dict, and we can further say pi minus 1, right? Pi minus 1. So that will be the maximum matches that they have, right? They have. So for this maximum match for this pi, so I know this is the length, right? This is the length. So for me, right now, cdict, right? Cdict pi, still pi. I'm looking at pi is going equal to 1 plus whatever this thing is, right? 1 plus, this is the previous, they're matching the length. We have the length. So that's the new length for me, matching for that. And once I'm done that, right? So that's just the two scenarios for the current pi. And now I need to check. So I need a res, right? So res length, right? And res position. So we need a two. Res actually and position. So res length is going to be 0 and position is going to be, let's just say minus 1. Doesn't really matter. So now I'm going to say if cdict pi, right? Cdict pi is from my current letter, right? I can match into pi, and this is the longest, and this is the length of duplicate string, the length. If this length is larger than res, right? If it's larger than res, then res length equals cdict pi, right? And res and position is equal to me right now, I, right? So once we go through all this, I collect a new cdict, then I say dp letter will equal to, well, dp letter not equal to dp letter, current position will equal to cdict, right? And once this is done, then we go to the next letter, and eventually we're going to return. We want to turn into one of them, right? So we're going to return. What do we return? We return s, right? And I have the end position, and I have the length. So it's going to be something to res position and but plus 1, and this is going to be res and position minus res length. Do I have to plus 1? Let's see. I think we need to plus 1. Because end position, let me see, end position, if I go 2, yeah, I'm going to plus 1. So this is going to have plus 1. So that's that. Alright. I'm not sure. This is very difficult. So we have banana. Yeah, bananas are good because it's deterministic. A, B, C, D. Oh, A, B, C, D, return empty string. How do we get empty string? I think we should get a 0. End position is 0, right? It doesn't matter if the length is 0. End position doesn't really matter. And of course, B by itself is going to be empty string. But BB is going to return B, right? S longest. Let's try it. Yeah, these pass, so we're gonna just give this a shot. Ay ay ay. Let's run. B B B B B. B B B B B B B B B B B B B. I don't know. Let's take a look. Yeah, look at this. Takes so long. Well, we can try it. Just see. See how this one goes. Judging. Judging. Still judging. Either wrong or we timed out. Timed out. So it's actually correct. Okay, so we need to figure out how to fix this. We passed 52. All right. So when we have, so the problem is if we have a gigantic, right, then it's O(n) squared, because here everything is going to be like this. The next one comes in, and I'm going to look at the previous one, and this p-dict. This p-dict is huge, right? This p-dict is huge. I have to go through every single one. What can we do about that? I mean, we can just try to pass by. Well, we can, let's say we counter everything, right? We do a counter, and then if there's one substring whose length is longer than half the length, larger equal to half the length, then it's guaranteed that this substring is going to. But how do you know it's a continuous, right? That's the issue. You don't know it's a continuous if you do counter. It could be not continuous, and you will fail. Like A, B, A, C, A, D, A, E, right? We can have half of the letters are all A's, and then it's not helping us at all. Okay, so the problem is the C-dict, the P-dict, right? The previous dict, is all the ones occurred previously. So I have all these occurred previously. And I need to go through every one of them to check. Now that is very slow, right? Very slow. How do I make it faster? But all of these are the ones previous. What if we can figure out a way to group consecutive together? Does that even make any sense? I mean, consecutives can only be matched with consecutives, right? You know what? Now I have other things to do today, so we're gonna leave as it TLE, and I'm gonna check the hint. Hint 1, binary search. Oh, interesting. So I'm going to try to, so this solution, write something. So this solution uses a dict to record all the indices, right? The indices of each letter in S. For each value in the dict, we record the length, the duplicate length, the dupe length, right? We record the duple length for each index and value. For each index, the value records the value of the dupe length when matching the current index and any of its previous, when matching the current index with any of its previous occurrences, right? Occurrences. Unfortunately, this solution runs in O(n squared) in worst case scenario, where all the letters in S are the same, right? So it passes 52 out of 66 test cases before timeout. Alright, let's see. Binary search for the length. If there is an answer of length 10, then there are answers of length. Okay, makes sense, yes. If there is a length 10, there gotta be length 987. Hint number 2. To check whether an answer of length k exists, we use Rabin-Karp's algorithm. What is Rabin-Karp's algorithm? What's Rabin-Karp? Rabin-Karp. Used for searching matching patterns in the text using a hash function. It does not traverse through every character in the initial phase, rather it filters characters that do not match and performs a comparison. I might have seen this before. Rabin-Karp. A sequence of characters is taken and checked for possibility presence. If the possibility is found, then character matching is performed. Okay, a text B and the string to be matched is this. Let's assign a numerical for the characters. We'll be using the problem. Okay, so we have a numerical for each one. N be the length of the pattern. M be the length of the text. Here, M is 10, N is 3. Let D be the number of characters in the input set. D be the characters in the input set. Okay. Here we have taken input set to be 10. You can assume any suitable value for D. Calculate the hash value of the pattern. Oh, wait, what? How? What type of hash value is hash function? Well, any type of hash function? Mod 13. So 344. Mod 13. Why do we choose a prime number such a way that we can perform all the calculation with single precision arithmetic? Wait. So this is 344 mod 13. That means we'll have 13 positions to place this. Any prime numbers? Let's keep reading. Calculate the hash function for the text window of size m. ABC is 6. Compare the hash value of the pattern with the hash value of the text. If they match, then character matching is performed. The hash value of the first window matches with P. You have too many things, so go for character matching between A, B, C, and C, D, D. Since they do not match, so go for the next window. We calculate the hash value of the next window by subtracting the first term and adding the next term as shown below. So what we're doing is, what are we doing? We calculate the hash value of the next window by subtracting the first term and adding the next term as shown below. So this is adding the next term, right? The previous one times 10 is adding the next term. And to optimize, we make use of the previous hash value in the following way. So let's say, what the heck is this? T minus V, character to be removed, times H. Times H. Plus, and D times, D is 10, times this, plus the new value, mod 13. Okay, I see what you're doing. I see what you're doing. So just the previous value. We need a minus the starting one, right? And times 10, and then plus the new one. Yep. If they're not the same, then go for the next window. After a few searches, we'll get the match for the window. The hash value is the same, and then blah blah blah. Okay. The hash value of the pattern matches with the hash value of a window of the text, but the window is not the actual pattern. It is called a spurious hit. Increase time complexity. In order to minimize it, we use modulus. It greatly reduces spurious hit. So I use modulus on the hash function. All right, I don't understand why we said give it below. The spurious hit. Wait, like any hash value, but why? I mean, there's the likelihood, right? The likelihood of them not match. But like, if I can pick a larger value, right? If I can pick a larger value, then every single one, the larger value you get, the less likely they're gonna hit, right? So I think it's a trade-off. If you get the value too big, then the mod might take a long time. Okay, now coming back here, so binary search. What do you mean by binary search? So we search the middle length, right? If we search the middle length, if it's good, we search on higher length. I see. Holy guacamole. Let's see if we can code it up. Wow, this is interesting for pattern matching, right? This is using both hints. So we're gonna say the mod. Let's pick a large value, right? Oh, but it's not gonna. Yeah, let's pick a large. Let's just say like 1, 2, 3, 4, 5, 6, 7, 8, 9. We know this is a. I think it's 9 or 7. I don't remember. Is this prime? The largest pair of primes in the form. Yeah, so both are prime. So they are prime. Okay, so this is our mod, all right? Then we just need to go the length res is going to be equal to, no, low and high. Right? Low, high equal to, low will be 0, length is 0. High will be length s, right? And we say while what? While true. While low is smaller than high, right? And mid is low plus high divided by 2. And then we just need to search, right? When the search for mid, okay. Search for mid to see if it's going to be a duplicate. How do I search it? So we get the first, right? And then we try to match everything. So for every window, hold on. How do we do this? So I have, let's say, a 3-character window, right? But I want to know if I can match another one. So I take the first one, and I go match. It doesn't match. What do we do? Get the next one? There's still a block. How? Whether an answer of length k exists. So, but I don't know where. All right? I don't know where. Like for this one, I can go BAN. I say, okay, I'm going to check BAN. And we check ANA. It does not match. Oh, then we switch to ANA. But it doesn't work. Oh, hold on. Hold on. What if we put it in a? What if we just put it in a set? Right? So we get this one, and then we get this. Doesn't match. Put in a set. Put in a set. Put in a set. Put in a set. I mean, I don't even need a mod. I'm not sure. Let's see. So we need a new set every single time. Sorry, right? So we're gonna just say a bag is gonna be a set, right? And then for I in range. So mid, right? We're gonna start with mid. 0, 1, 2, into mid minus 1. We're going to go all the way to the end. So n equals len s. Right, I'm going to all the way to the end, and we say current string. Right? Say the current string. So the current string is going to be s I. So it's going to be I plus 1, right? This is going to be I minus mid. Hold on. I is this. So minus mid into plus 1. Yeah, so this is the string. I would say current str is equal to this. Let me say if cstr is not in bag dot add cst right? We're gonna add cstr. Okay. Else, if it is in, right, then we break. Else we break. So else we can break. And when it come out, basically we say if we find the entire thing, we do not find it, right? So else is we go through the entire thing at this length, we do not find it. If we do not find it, that means this length is too big. Then we're going to say high is equal to high going to equal to mid. Let's say we're gonna coming down from the top. So let's say high equal to mid minus 1. All right. So it means otherwise I break out and then continue. Otherwise I break out. That means I found it. Right, I found it. If I found it, wow, looking awesome. If I found it, right, that means we found it. Right? We found it. So so we can search for something bigger, right? We're gonna search for something bigger. Okay, so we also need result. So we need to know res, right? So back at else is in bag. So we're gonna say res equals cstr, right? And then I break. And break out, I say low will equal to mid. So low move to high. And then we do this again. Right, when I check again, and then either I found it or not find it. If I find it, then low we keep pushing higher until we don't find it. And I'm going to try it again. We don't find it, and we come out. So I'm going to return res. Oh no, I think we hit some issue. Why? Mid -1 to n. Hold on. So I is in this range. So, but I have a low and a high, right? Low and a high, they are the length. Come on, they're the length. Low and high are not indices, they're length. So low length, high length, mid is the length, right? The length. So if mid is the length, 0 to I plus 1. Yes. Yes, that's the mid is the length, right? Mid is the length. So mid is the length. So I is the position. So it has to be this. I starting from this position. So from I to the front. Okay, where do we have the issue? Let's check the first one. See, yep, the first one's good. The first one's good. I think the issue is the second one. Is the second one. Right, it's the second one. Why? So the second one we start and low equals mid. I didn't find anything, right? So I can just print low and a high and see what happens. So print low and a high. So we stuck at 0, 1. So else high is mid -1. So now low and high is 0 and 1. Mid 0 plus 1. Mid is 0. Which means the length is 0. So while low smaller than high, and the mid has to be so mid equals this, right? And if mid is 0, that means we also break. We say if mid is equal to 0, then we also break, right? Then we only need to go 2 passes. So this means no more the current dupe string length is 0, so no more search needed. Okay, so now let's try it. Oh, we hit another one. That's probably this one. Let's see. No, this one's good. It's this one, B and B. So if B and B, what happened? Print low and high. 1 and 2. 1 and 2 is 3 is 1, right? And if it's 1, then mid is 1, right? So we go from 1 minus 1 from 0 to n, and for each one, you should be able to find. And then break, 1 find, and low equals mid. Go back to 1. I go back to 1. Therefore, while low is smaller than high minus 1, because if they're right next to each other, then it will fall onto the lower one. So I think it's, and then we don't need this, right? And then we pass. I think we pass them all. All right, let's see, using both hints. And then in this case, we don't need mod. We just need a hash function. We just need any hash function will work. I say run code. Yep, try it. I got a wrong answer. Probably because expected, so we have a 3, and then how about I'm now just throwing things randomly. How about I still do this, right? This, and then answer. It doesn't really matter what answer is. The answer is just, all I need is the length. Right? We just need the length. So when I check, I just need to check the length is equal. If length of this is equal to length of this, then we're good. What the hell happened? Oh, I know what happened, because I remove it. So my point is coming down, and we say if. Alright, so we go through everything, and we say if mid is equal to, is smaller than 2, then we break. No, that ain't work. How will this not work? Okay. Okay. Wait, are you telling me these all pass? Is the last one? What? That's ridiculous. How? It passed here. Right, it passed here, and then let's see, I'm gonna use this, right? I run it. Yeah, give me wrong answer. And I do this. Yep. And if I do this, it goes forever. low and high, 3 and 4, right? So it's 3 and 4. How do I handle 3 and 4? And currently, oh, I see. Okay, handle this way. Let's say low, always low plus 1. Yep, low plus 1, because low plus 1, because this biased towards low, right? So if it's 3 and 4, we always go back to the same value. So if this one go forward, okay, in this case, I think they all work. All right. Hopefully it's the last shot. Come on. Come on. Come on. Yes. Yes. Wow, we used a hint. Huh. So I'm gonna two key insights, right? First, binary search. This is the most important part. This is the most important insight. We can start with half. We can start with half the length of S as a potential answer. Now, if we can find dupe at this length, that means thus we binary search for a higher value. If we cannot find dupe at this length, that means the dupe substring must have lower length, right? Lower length. Then we binary search lower. Then we binary search the lower half. And each time, second is, I mean, I don't really think it's really necessary. But so using a hash, using a set to quickly check whether a substring, whether there exists dupe of a for substring of a given length. Now this is touted as the Rabin-Karp algo, which uses modulo as the hash function. But in our case, we can simply use a set to serve as the hash function. But maybe the modulo is faster. With these insights, the final difficult part is to determine, right, how the low and high shall change during binary search. Now, if the condition is low smaller than high, we know one of these two needs to change after each round. So is it high minus equal 1 or low plus equal 1? It's the latter, because the computation of mid bias towards low. If we keep low the same, we will run into the situation where low equals mid plus 1. No, low equals not low high. Well, high equals low plus 1, and mid will equal to low plus high divided by 2 will equal to low, right? So we're running into the situation where, and this causes infinite loop. Hence, we use low plus equal 1 at we use also plus equal 1. So the runtime will be O n log n, and we hit a 2992 milliseconds or a 43% ranking. Alright, that's it. That's it for today. I need to do something else, but I think when I get back, I'll check smart people's answers. It's all over the place. Alright, that's it. Well, it was a hint, but it's good enough, right? Alright, that's it for today.